Hello everyone, welcome to this video. In this video, we'll be looking at another question from linear algebra. It appeared in the exam 2020. This is a multiple select questions, that means multiple options could be correct, and it is a 2-mark question. So here in this question, they are asking if you are given this system of linear equations here, right? So 3 equations are given to you with 3 unknowns x, y and z. Then they are asking the system is consistent if what among these 4 is correct, right? So let's have a look at the solution for this question. So first of all, you should know what is the meaning of consistent solution. So you should know what is a consistent solution. When do we call a solution to be a consistent solution? Whenever solution for the given linear system, that exists then we call it to be, then it is consistent. That means it should not be the case of no solution. So we have 2 categories. Firstly, the unique solution, in fact 3 categories: the unique solution, infinite solutions and no solution, right? That you have studied already. So these 2, unique solution and infinite solution, comes under the category of consistent solution, and this no solution comes under the category of inconsistent solution. So here we are required to look at the cases where we either have unique solution or we have an infinite solution. So what we can do, we can make cases here. So we in the first part, so firstly we could say when m is equal to 4 and k is equal to 5, because in the options you are given the value m is equal to 4 and the value k is equal to 5. So what possible options are there? Either m is equal to 4 or k is equal to 5 is there, or you could have m is equal to 4 and k not equal to 5. It could be any number. In the third case, what option can you have? You could have m not equal to 4 but k equal to 5, right? And in the fourth case, what option could you have? You could have both m not equal to 4 and k not equal to 5. These are the possible cases. So let's check them one by one. If you take one, that means m is equal to 4 and k is equal to 5, what does your system now become? You have the first equation as such: x plus y plus 5z is equal to 3, right? X plus y plus 5z is equal to 3. The second equation becomes x plus 2y plus 4z is equal to 5, and the third equation becomes x plus 2y plus 4z is equal to 5. In place of m we have substituted 4, in place of k we have substituted 5. So we could write this system in terms of matrices like this: 1 1 5 colon 3. The right hand side is written after the colon, right? So you have 1 2 4 colon 5, and then you have 1 2 4 colon 5. So this system you have with you, right? Now for the system we wanted to check for unique solution, infinite solutions or no solution. So what we'll do, we will convert it into the corresponding echelon form, a form in which the first entry is 1, the remaining entries they are zeros, right? And then this entry is 1 and the entries after it they are 0, and then we have to make this as 1 in order to make it echelon, right? So we have to perform certain row operations on R2. Because this is 1, we wanted to make it 0 using this element over here. So we'll apply on the second row the operation R2 minus R1. And similarly for the third row, we wanted to make this element as 0, so we'll apply the operation on R3 as R3 minus R1. Why using R1? Because we wanted to keep the element as such, right? Okay, so let's perform the operation quickly here. So the first row would be as such, it would be 1, 1, 5 and 3, right? The second would be 1 minus 1, that is 0, right? 2 minus 1, that is 1, 4 minus 1, that is minus 1, right? And then we have 5 minus 3, that is 2. Next, for the third row, it is 1 minus 1, 0, 2 minus 1 is 1, 4 minus 5 is minus 1 and 5 minus 3 is 2, right? So this is the matrix that we obtain after performing these row operations. So let's have a look here. Now we wanted, this element is already 1, so no need to do anything. We wanted to make this element as 0. How we can do that? We have to apply the operation on R3 as R3 minus R2. Here we have to use the second row. Why? If you use the first row, this element would change here, right? This element would change here, this element. Okay, so when you apply this operation on R3, it would be 1, 1, 5 and 3. The second one would be 0, 1, minus 1 and 2. Then it is 0 minus 0 is 0, 1 minus 1 is 0, minus 1 minus minus 1 is 0, 2 minus 2, that is 0. So you see the last row here is 0. So in this case, if you see what is the rank, if you call this much as matrix A and this much as matrix A colon B, so now you wanted to see what is the rank of A and what is the rank of AB. So you see in this case the rank of matrix A, that is equal to 2. Why? Because the third row is 0. So in this case we are only looking at this much portion. So here the rank is 2. The number of non-zero rows here are 2. And similarly the rank of A augmented B matrix, that is also equal to 2. In this case we are looking at whole of this matrix, right? So in this case it is also 2. So you see both the ranks, rank of A, that is equal to the rank of A augmented B. So that means, but however it is less than 3. It is 2, right? This is equal to 2, which is less than 3. And what is 3? The number of unknowns. You have 3 number of unknowns x, y and z with you. So in this case this is the condition for multiple solutions. So it is a condition for, so we for this case we would have multiple or infinite solutions. If that is so, we would have the system as consistent system. So you see, if that is so, that means we have a consistent system. That means m is equal to 4 and k is equal to 5 would do return you a consistent solution, right? Now let's move on to the second case where we wanted to see m is equal to 4 and k not equal to 5. So we will put m is equal to 4 and k not equal to 5. So if k is not equal to 5, we'll keep it as such and then proceed further. So in this case, what would your system become? The first equation would be as such. It would be x plus y plus 5z is equal to 3. The second one would be as such, right? Let's see, where do we have m? We have m here in this one, right? So in place of m we would have 4 and k would be as such, right? So let's do it quickly. So the next one is x plus 2y. In place of m we are substituting 4 here, so it is like this. And the last one is x plus 2y plus 4z is equal to k. So we could again convert this into the corresponding matrix form. It is 1, 1, 5 and colon 3. Then 1, 2, 4 colon 5. We are just writing the coefficients. 1, 2, 4 colon k, right? So these are the values. So here again we would like to make our matrix into the corresponding echelon form. So on R2 we'll apply the operation R2 minus R1, and similarly on R3 we'll apply the operation R3 minus R2. So the matrix that we will get afterwards is 1, 1, 5 colon 3 as such. The first row would be as such: 1 minus 1 0, 2 minus 1 1, 4 minus 5, that is minus 1, right? And then 5 minus 3, that is 2. And the second operation would be, it is 0, right? And then it is 2 minus 2 is 2 minus 1 is 1, 4 minus 5 is minus 1, and then k minus 3. This is what we have here, right? And then next we wanted to make this element as 0. How we can do that? We have to apply the operation on R3. So on R3 we'll apply the operation that R3 minus of R2. So let's see what do we have here. After applying this operation, the first row would be as such 1 1 5 colon 3, right? I'm sorry, here it should be R1 because we will be using only the row first for this operation. Why? Because that row would be kept unchanged. Okay, the calculation are okay. So 1 minus 1, that is 0, 2 minus 1, that is 1, 4 minus 5, that is minus 1, k minus 3. Okay. So in this case, we are applying the operation R3 minus R2 on the row R3. So that means second row would be as such 0, 1, minus 1 and 2. And the third row would be 0 minus 0, 0, 1 minus 1, 0, minus 1 minus of minus 1, that is 0, k minus 3 minus 2. So that means k minus 5, right? So it is k minus 5 here. So in this case, if you see, what is the rank of matrix A? What is the rank of matrix A? For matrix A, we will be looking at this much portion only. So you see we have 2 non-zero rows, so that means the rank is clearly 2. What is the rank of A augmented B? The rank of A augmented B now depends on K. And what is the condition here? K cannot be 5. If K is not 5, that means if K is not equal to 5, that means K minus 5 cannot be 0. If that is so, this element cannot be 0. That means for A augmented B, we have 3 non-zero rows. So the rank in this case is 3, right? So the rank in this case is 3. If that is so, both the ranks, they are not equal. Rank of A is not equal to the rank of A augmented B. So in this case, we would have no solution. If that is so, we have an inconsistent solution with us, right? So here, that means K is equal to not 5 cannot be there. So K not equal to 5, the option B is incorrect. Let's move on to the third one. For the third option here, we are taking M not equal to 4, but K is equal to 5. If that is so, what is your equations here? It is x plus y plus 5z is equal to 3, right? X plus 2y. Now in place of M, we'll just write M because it is not equal to 4. It could take any value other than 4. And for the last one, it would be x plus 2y plus 4z is equal to 5. In place of k, we have substituted 5 here. So in matrix form, it is 1, 1, 5, colon 3, right? Next, it is 1, 2, and then M and 5. And the last one is 1, 2, 4, and 5. Now here again we wanted to make this matrix into the corresponding echelon form. So here we'll apply the operation on R2. It would be R2 minus R1, right? And on R3 it would be R3 minus R1. Simple as that. So it is 1, 1, 5, colon 3. Then it is 1 minus 1 is 0, 2 minus 1 is 1, M minus 5 is M minus 5. Right, because we yet do not know what is the value of M. Then 5 minus 3 is 2. The next value is 1 minus 1, that is 0, 2 minus 1 is 1, 4 minus 5 is minus 1, and then you have 5 minus 3, that is 2, right? Next we wanted to apply the operation on R3 using row 2. So we wanted to make this element as 0. So we R3 minus R2, right? Same as previous. So the first row would be as such, no change in this. The second row would be as such, no change in this. For the third row, it is 0 minus 0, 0, 1 minus 1, that is 0, minus 1 minus M plus 5, that is this element minus this element, right? How much is that? Minus M plus 4. So 4 minus M, right? and 2 minus 2, that is 0. So this is your matrix after converting it into the echelon form. Now we wanted to see what is the rank of matrix A here. So rank of matrix A would depend upon M. Now in this case, if if we already know what is the value of M. M is not equal to 4. We already know M is not equal to 4. If that is so, if you shift M to the left hand side, so that means M minus 4 would also not be equal to 0. If that is so, if this is a non-zero quantity, this number is non-zero, you know, this is non-zero. So that means how many non-zero rows are there? So there would be 3 non-zero rows, right? If that is so, you have the rank as 3. And what would be the rank of A augmented B matrix? Again, because we know M is not equal to 4, we would have 3 as the number of non-zero rows. So that means both the ranks, they are equal, and both and they are also equal to the number of unknowns. So in this case, we would have a unique solution with us, and it is also consistent. So that means M not equal to 4, K is equal to 5 could be the case. And lastly, we have to discuss the last case, which is the case of M not equal to 4 and K not equal to 5. So you see, in our case, we have crossed out this option B, K not equal to 5. So this case would also be crossed out, right? So we only have these options with us. K not equal to 5 won't give us any solution, because we have already we already saw it with M is equal to 4 and M not equal to 4. That means we have already, whichever value of M you take, for K not equal to 5, you are always going to get an inconsistent solution. So no need to discuss this fourth case. So in the fourth case, because K is not equal to 5 would give us only inconsistent solution. Why? As we have discussed above, right? So that means the correct option to this are when we have M not equal to 4, K is equal to 5, and when we have M is equal to 4 and K is equal to 5. So that means K is equal to 5 is definitely there, M is equal to 4 is definitely there, and M not equal to 4 is definitely there. So I hope you understood this question well. Well, that is it for this video. Thank you for watching.